Because it's better. All right, here we go. We're doing our first trig proof today. That's what we're going to do. We're going to do a proof. We're going to prove something. Let's prove something. Intro to what's going to be happening. Did you guys hear the cheers on the video? Make sure to like and subscribe and hit the bell. I don't care what you do. All right, so I'm going to graph y equals cosine of theta on this. I should be able to do that relatively quick at this point, right? Thank you. Because what's cosine? Cosine, I start at a max, intercept, min, intercept, max, right? Now they want me to graph it from negative pi to 3 pi. What do I do with my pattern? I just keep going, right? And it goes on and on and on. Don't get me monetized or demonetized. I need to get remonetized. All right. Do you all agree that this is cosine, good old cosine of theta in blue? All right. Now what I'm going to do is I'm going to graph y equals sine of theta plus pi over 2. So let's use our rules. What's xy going to go to with this equation right here? What's going to happen to my x? If I add pi over 2, what's my x going to do? We're not multiplying. We're gonna shift it, right? This is our first phase shift. So this is an intro to phase shifting, right? Remember, if it's plus, we go left. So I'm going to take my x and subtract pi over 2, and my y will remain the same. Now we're graphing sine. Remember, sine starts at 0, 0. So where's 0, 0 going to go for sine? What's 0 minus pi over 2? Negative pi over 2. And what's 0 times anything? Watch this. Now I'm graphing sine of that. Where's my first point? Right there. Now my next point is usually what? Pi over 2, 1, right? Because we're graphing sine. 0 max, 0 min, right? Intercept, max. You guys remember this? It's a nice review if you don't. So what's pi over 2 minus pi over 2? 0. The 1 stays the same. Look at that. What's up? Remember, anything that happens in the parentheses, because remember that theta's are x. Anything that happens in there is opposite. Remember, like, does that ring a bell?
Yes.
If it's outside, it's real. Because if I had a plus 1 out here, it's technically y minus 1 equals that. It's technically always opposite of what's happening to it. All right, what do you think is going to be my next? What's up?
If I think of that as like on the circle, like if you add like 90 degrees, you go like
You're starting.
to the left.
Yes.
Okay.
You're pretty much starting. You're adding. Actually, no, you'd be starting down here. Because then you'd get. Oh, no, yeah, because, yeah, you'd start up there. Yeah, because it's, yeah, you're right. Now, do you want me to go through all these, or are you catching a drift? Hold on, let's do one more. What's pi minus pi over 2? Pi over 2. Look at. What's my next point going to be? Pi, negative 1, and 3 pi over 2, 0. So if I draw in purple my sine of theta plus pi over 2, What's true about those two functions? They are equivalent. This is your first trig identity. Sometimes you want to convert your equation all to sine. So now I can take any cosine and convert it to a sine, right? I would just add a pi over 2. Does that make, like... No, they are. That's the point. I'm saying when we're solving equations, if you want everything to be in the same sine or cosine, we can do that now. When we get to solving trig, you're going to see why we're doing this.
You just make an app. Are you just making words app instead of
Apps. No, I'm so confused now. I'm happy you on Online World didn't hear what they just said. All right, let's get more confused. If you weren't confused, let's get confused. I'm so confused they call me Confucius. That's not true. No one's ever called me that. No. Oh my gosh. Yes. All right. The Romans. The myth of how it started. All right. All right. Let's do this beast. Never. All right. We got. Can we do the video? All right. Hey, just so you know out there, if anyone's not a part of my classroom, it's snowing outside. And when it snows, kids get all loopy. And my kids are being loopy. Shh, don't use his name. All right, here we go. Midline. We've done this before, right? We've been finding midlines. So again, sorry, might be a review. Let's use the graph of the midline to come up with our amplitude. All right. So how can I find the mid? Is there a mathematical way to always find the midline?
Yes.
What's my amplitude from here to here? How big is that? 6, or that's not my amplitude, but that's my distance. What's half of 6? 3. So if I go 3 down from here, I'll get my midline, right? That's how I'm always going to find my midline. Find the height, divide in half, right? So based on that information, what's my amplitude of this beast going to be? My amplitude is going to be 3. What is my midline? What equation is that? Y equals 2. Horizontal lines is y equals. Ta-da! That's all I had to do, right? So let's do this one. What's my height from here to here? 10. What's half of 10? So I go 1, 2, 3, 4, 5. Y equals -3 is my midline. Okay. What if we didn't have a graph and we had to find midline? What would I do? Quit? No, it's actually... What is the midline of a normal sine or cosine graph? Would you agree it's y equals 0, right? So on A, what are we doing with our graph? We are moving it down 5. So what's going to happen to our midline? So you agree it's y equals -5? So when I go to graph this, I could draw in a new midline to help check myself because I need that for my intercepts, right? I need the midline because technically if I move the midline, my intercepts are now on the midline, not on the x-axis. Uh-oh. What about that negative, though? What do I have to do with that? Nothing. But you flip the graph. But for your midline, it's going to be the same. So what's my midline of this one going to be? All right. Let's learn something new. Sinusoidal. Like I have a sinusoidal infection. Why isn't this going on to the next page, though? Is that it? We're done.
We're going to learn all the trade secrets.
Uh-oh. 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 This is a great video, guys. Don't look at this.
I don't know if you can really see it.
Uh-oh. Uh-oh. That's it. I'm getting demonetized. Let's try this one. Is this practice? Get out of here. There we are. All right. Because I didn't do the thing. All right. Let's talk about this. We're almost done for the day. So, we talked about sinusoids. We can do anything that's a sinusoid. Period, we know, right? It's 2 pi over absolute value of b. Period, we know. We've talked about it. Frequency is a new term. Frequency and period are two different things. Think about period is how long does it take for one cycle of your graph? You know what I mean? If my period is 2 pi, it tells me that it takes 2 pi for one cycle, for it to go up and down and up all around. Frequency is cycle over time. What does that mean?
The amount of cycles.
Exactly. This is how many cycles can I complete in a given time. Does that make sense? Period is how long it takes for one cycle. This is how many cycles in a given amount of time. If you do anything with physics, you need to know the difference between these two things, right? Frequency. When have you heard frequency before?
Radio.
Radios use frequencies, right? That's how compressed the waves are. Walkie-talkies use different frequencies because then they are only looking for waves of a certain size. It's magic. No. I don't. I do. I just said, yeah, I know. I have a master's in physics. All right. All right. Let's use the equation to find the period and frequency. This doesn't take long. What's the number in front give me? Amplitude. What's the number inside give me? B, right? So what's my period? How long does it take to complete one cycle of this beast? Well, it's 2 pi over 1 over 4, which is 8 pi. That means one wave is 8 pi long. Yes. Yeah. Circles. What's my frequency? That's going to be 1/4 over 2 pi, right? I flip it. Now, if I know period, do I have to recalculate or could I just find the reciprocal of that? It's the reciprocal of that. It's going to be 1 over 8 pi. Okay? Because you complete one cycle every 8 pi length or time. It's usually time. Yes, always. These are always reciprocals. Always. This one's more used in physics. This one's more used in math. I use this one periodically. Thanks. All right, let's do this beast. What's my period? 2 pi divided by 48 pi. What happens to my pi's? So I get 1 over 24. That's 1 per day. Yeah, because if you had hours. So what's my frequency? 24. Let's do a real life problem. You need to hyper focus on this one. Because this is what you're going to see. These are called oscillation problems, and they're very common in physics and in calculus. Because what's in a lot of vehicles and things with engines and stuff, and suspensions, how do they work? With springs, right? So guess what happens a lot in math? You're dealing a lot of times with springs. Make sure you get new leaf springs when they break. One time I If anyone here knows cars, one time I broke my sway bar going down a road in Saginaw because I actually got air because there's a giant pothole. Breaking a sway bar is kind of crazy. It went pop, pop. It sounded like a gun went off because it was so loud. I just cracked it. I kept driving. It's just your car, it wasn't very good. All right, another time my wheel fell off. All right, so same car. All right, a mass on a spring. So if I drop it, what's that going to do? It's going to bounce, right? It completes one cycle in 0.25 seconds. Its maximum displacement is 6 centimeters. Write the equation for it. I can't guarantee it, but I almost guarantee you're going to see a problem just like this. Well, I know you will on testing here. And on the AP test, I almost guarantee it. These are really common problems. So if I drop it, what's it mean max displacement? That means how far it's going to go. This is where I'm starting. So if I drop it, how far down is it going to go from here? 6. Displacement is distance away from where you start. We're going to have to learn some physics here as we go. Think about this. If I went like this, and I went like this, I traveled, right? I had a velocity. I moved like 10 feet. What's my displacement? 0. Yeah.
So is it 6 up?
Yep. Because what's going to happen with a spring when you bring it down? What's it going to do? Blow back up. So if it goes down 6, then it's going to go up 6. So what's my amplitude of my wave going to be when I graph it? Because when I release it at 0, it's going to go down, up. Hold on, though. I graphed that wrong. Why did I graph it wrong? What are they denoting as D? They're saying we're measuring that. That's what we're measuring. So that can be a negative value.
Yeah. No.
That's a positive value. That's D. If I measure that, that would be positive.
Just look at all the distance. You can't make it. Yeah. It just wants. Yeah.
Yeah, they're doing release. Could you fight it and use a negative and get similar response? Yeah, but no, they're denoting the distance as traveled from there. So be careful. The biggest thing I want you to realize is what's your amplitude that's going to be? D is going to be equal to 6. Now, oh, that won't matter. Do they want the equation too? Ooh. Okay. Okay, I see you. I disagree with that. You can fight for either way on this one. Do you guys want to start at 0 or cosine? We can do sine or cosine. Which, you guys want to do sine? So we're going to start at 0, and it's going to displace. We'll do sine. Now, it completes one cycle in 0.25 seconds. What's that mean? Is that my period or my frequency? It's one cycle. Which one gives us a cycle per time? Which one's cycle over time? Okay, I should say that.
Yeah.
Do they give us time or number of cycles? All right, which one has time on top? Okay. We got there. All right, so what's my period? What's my equation for period? It's what? Time over cycle. I guess could I found the frequency and use that to reverse engineer? Like, because I want the period to plug into my equation. What's my time? 0.25. How many cycles do I complete in that time? 1. So if I found I could still find frequency. That would be cycle over time, right? They both work. What's 0.25 divided by 1? It is 0.25 because you're dividing by 1. It's 1/4.
Yeah.
What's that one then? 4. How many quarters make up a dollar? 4. Or you could just say, what's anything divided by 1? It's itself. I'm not calling you dumb. I'm not calling. No one is dumb. All right. So that's my frequency is 4 cycles per. So I have 4 cycles per second. Right? And I'm going to complete in 1 second. I'm going to do 4 cycles. They're saying the same thing, right? Okay, good. We all agree on that. So from there, I need to find my B. I wouldn't use theta. Why not theta on this? Am I dealing with angles on this one? Ooh, what am I dealing with? Time. I'm plugging in time, finding out where it is at any given moment, right? So how do I find B? 2 pi over B equals what? 1 over 4. Right? Yeah, you can cross multiply. So I get 8 pi equals B. So do I have an equation? What does this equation give me? Will I know where that weight is given a time? Yeah, I plug in there. It'll tell me where the weight is. I'm going to this is how molecules move. They go like this. There's sine and cosine curves. If you want to know where a molecule is at a given time, that's like it. That's it. You can take a guess.